Just wanted to introduce myself real quick. My name's Paige Thomsen-Russ. I've been an agronomist for 2.5 decades. I've had many experiences in the ag industry, from retail, independent agronomist, seed production agronomist. I'm really excited to be in this soil health space and visit with you all today about scouting for success. The agenda for today, we're going to be talking about mainly scouting, recognizing early visual signs of crop stress, deficiency, possible early disease, using tissue testing and other testing to guide, decision making. There's a lot of technology out there. Drones, imaging tools can definitely enhance your scouting also. And then getting that spade out and doing some digging and looking below that soil. So, all right, so tissue testing. This definitely can help growers identify nutrient deficiencies early on. So it can tell a story throughout the season. I do like to take weekly tissue tests throughout the growing season. It can help fine-tune those fertilizer applications if there's a need for that, or other things that can help enhance the crop as far as if you're seeing some deficiencies out there. It's also useful when you have areas with poor growth versus normal growth. It's used in conjunction with, your soil testing to fully understand those nutrients and the nutrient status. So on the corn side of things, early on, the V4 to V6 sampling above ground level portion of, I'd say, 25 leaves. V9 to V11, sample that first fully developed leaf with collar from 15 to 20 plants, and then the reproductive stages, the leaf opposite below the ear at silking. I haven't done too much tissue sampling in soybeans. It seems like there's always just a big ask and need on the corn side of things, but if you're curious, soybeans, you can select that most fully developed leaf, that top trifoliate leaves. You don't want to include the petiole on that. And then on the alfalfa side of things, that top 6 inches of the plant at that early bud stage. So plant sap analysis is definitely another way to monitor crops. And the plant sap analysis, it's been a tool for a little over 10 years. I would say it's really ramping up the past 4 years. In my territory, I know I have a couple of growers that are utilizing this to monitor their crops. So it enables the grower to forecast periods of nutrient deficiency. So it can be a real-time information, and there are also labs that analyze this as well. So to perform a plant sap analysis, you take a small amount of the sap, that plant's blood, I like to call it, is drawn from the plant stems or leaves and evaluated with various nutrients. This analysis is super important to determine that nutrient deficiency imbalances that could impact yield and plant growth. But again, just another way to analyze that crop so the grower can adjust their fertilizer to reach production goals while reducing that environmental damage. So another way, as far as to monitor plant stress and just knowing what's going on, is doing a Brix test. And it's basically a scale measuring the sugar content based on light refraction index. So a high Brix level will show stronger natural defenses against insect and diseases. A low Brix level will basically shows that there's an increase in likelihood of a bacteria or insect or fungal attack on that plant. Yes, there does come back average readings, which still suggests there is a possibility of stress and trouble. But again, this is another way to check that plant stress and monitor that field. Go to the next slide. Drone use in monitoring crops. I've been flying drones for 13 years, and the perspective from up above, that image alone is just amazing. It can tell a story in that field all in itself. Now, there is software, there's apps that you can have also as far as connected to your drone to, look at stand counts and plant health. And, just a few that come off the top of my head. I know there's a lot out there. I've had experience with drone deploy, Centera, but definitely another way, to monitor those crops. That picture in that top picture, I took that in an extremely wet year. You can see the yellowing out there. You can see, as I ground truth that field, yes, it's very heavy, wet soils. So you have to think to yourself as somebody giving recommendations and growers, where's that plant at in its stage of growth? What can we do to change that? Would there be a benefit of added nitrogen or nutrients? But all things that you have to think about. But seeing that image and being able to go in those areas where you see that yellowing is very beneficial. And then that bottom picture, I randomly took my drone up, just helping out a farmer that's curious, what his field looked like. And lo and behold, saw there was a little mishap from the nitrogen side of things. So this was very helpful. It was well before tassel. They're able to go in there and put some supplemental N in that spot. But again, drones are great tools to monitor crops, to catch things early. There's also other imaging tools, such as, Ag MRI, climate field view, just to name a few. And this is actually from the climate side of things. Just wanted to give a quick visual of a few fields in my account that I've scouted in the past. The first picture is the scouting image, that, red, yellow, green. It kind of directs you and guides you where you need to go as far as to look in that field. And the picture next to it is the vegetation image. And that's the one that I really look at to be like, okay, do we have a serious problem out there? So you can see in that first field, it's pretty yellow, light green cast. There's something definitely going on out there. And then as far as that second image, you can see that vegetation image is, kind of consistently darker green. That might not have too much separation between the good and the bad, but definitely this gives you an idea as far as, where to start scouting, to ground truth things, to see what's going on. You can go to the next slide. And again, I'm just giving some examples that I've had experience with. There are so many tools out there, but hopefully this will just help, guide you and let you know, what is out there. Ag MRI has been a really neat tool also, as far as, diving and digging a little deeper. You can see the weed pressure here, the underperforming areas, the nutrient deficiency, disease risk, and you can dig deeper by each field. So that first picture is that disease risk. So you can see the yellow is popping up. It's showing, hey, there's something going on out here, likely disease related. So you can spend your time efficiently in looking in those areas. And then as far as the nutrient deficiency, that second photo, you can see there's just a few spots lighting up as far as showing some possible deficiency. So if you go to the next slide, it kind of digs in a little deeper as far as what we could do with this particular imaging tool. So it gives a little report, as far as how many acres is affected, saying that there's possible signs of nutrient deficient plants. They've been detected in the field. The crops in this area have a suspected deficiency of 4.8 acres. So it gives a little more context of it, and then give you a better idea. But again, just two quick examples of some imaging tools and resources to help monitor crops. You can go to the next one. There's also ways as far as to monitor plant health and disease and insect tracking out there. And I know tar spot has been a really big buzzword in my neck of the woods. And there's many different monitoring tools. I've got one down there, but there's also an app called the Tar Spotter app. And that one's been an interesting one too, to kind of put in actual fields, and it tells you exactly what type of risk you're going to have. But right now, this is what things look like as of June 28th. I did pull this as far as the yellow is lit up. It's showing that this is where tar spot has been found this year. The gray area shows that that's where it's been found in the past. The inoculum is out there, and it's something to have in the back of your mind. But as you know, to get that disease model to kick in, I mean, you need the disease, you need the right conditions out there. So you just never know. This will just give you a guide as far as where to focus on. And then I just picked an insect that's kind of newer, mainly in the Nebraska area, a little bit into western Iowa, South Dakota, Minnesota, as the soybean gall midge. It's a tough one to manage as well. So they're able to do an alert network on that as well. Moving right along, examining roots. I really enjoy this time of year as far as getting my spade out, digging below the soil. We see what's going on above the soil all the time. And sometimes there's things going beneath the soil that maybe will help us understand, what that crop is going to do later on. So that first picture, as far as with the roots, with the soil hanging on to it, looking at that rhizosheath, the complex of root hairs, exudates, and soils that strongly adheres to the plant. It is interesting to see, if you have a healthy soil, you're going to have a really nice rhizosheath there. So root to microbe associations does boost that rhizosheath formation, and it can be a feature that can help in drought conditions. So that middle picture, there's some compaction going on in a couple of fields that I looked at. That first one, came up against a hard pan. That root system was going out instead of down. And then the other one next to it, sidewall compaction, getting that tomahawk roots. And, sometimes you might not see above ground symptoms at that moment, but, later on in the season, if the root isn't anchored in the soil, you can see some things, whether it's standability or some lack of nutrients that it's uptaking later on. But again, can't fix the compaction piece of it at the moment, but you can definitely do things as far as possibly enhance that crop later on. So the picture next to you can't see it very well, but there's a corn rootworm larva. There's some areas in the state that experience corn rootworms more than others. And that is one thing that, you have to dig plants to know what you have going on out there. And it's one of those things where likely you'd have to make decisions that next year as far as if you need to add traits to your crop. But you can see the picture down below. You have a really, to the left, you have a really nice root system and those 4 plants. It's white, healthy. You have the nodal roots, those brace roots developing. And this is in a field that had a side-by-side of a crop that had fully traits. And then the next one next to it that was split planted didn't. So you can see those corn rootworms really annihilated those roots, and that's going to have some issues later on in that season. Again, with the root side of things, soybeans, super important to monitor that as well. So what is the color of the soybean nodules? What does it mean? The pink and red nodules, they are actively fixing atmospheric nitrogen. Green, brown, or mushy, it's not actively fixing atmospheric nitrogen. Could possibly be due to flooding soils or maggots or larvae or pest that's affecting it. And then if you see white or small nodules, they may not have started fixing atmospheric nitrogen. And then looking at the number of lateral roots and root hairs and number of nodules can help you determine the health of your soils and your crop. Not all areas experience soybean cyst nematodes. The bulk of my territory does. That first picture, there's 61 soybean cyst nematodes on one soybean plant root. That's definitely a lot, and you definitely see some above ground effects from that, especially if you have higher pH. Typically, it goes hand in hand with that. This cyst feeding can disrupt that plant's nutrient absorption and leading to the yellowing, stunting, and loss of yield. Getting to know your soils even further, examining them. That first picture, I was in a field the other day, no-till since 1980. They use cover crops and adding microbes to it, and you can see those earthworms. You can see that big earthworm hole, and definitely that picture next to it is the soil from that field. Also, it was crumbly. The soil structure was really nice. A lot of aeration in there. The one next to it, where you can kind of see a little bit of clay included in that. Compaction or just knowing your soil type is definitely important as well. And then that last picture is mycorrhizae growth in that soil, which is definitely, I'll get into that a little more in the next slide and further in the presentation. You can go to the next slide. Kind of talked about this a little bit as far as, looking at that compaction piece. There's tools out there that you can use, such as this one as well. I don't need to go too deep into this. So you can keep going to that next slide. There's tools out there also that are real-time, AI-based, getting a baseline out in the field, checking to see how things are going, getting that baseline, and in that moment, you can, get an idea if, you think you need to add any type of nutrient or just to see how things are going. And, I think this tool is great as far as, like I mentioned, getting that baseline, checking it again throughout the season. I would say even 1 or 2 times throughout the year to see how things change or move, anything like that. But, I like that it shows the nitrogen, the P and the K, the pH, organic matter, CEC, micronutrients, bulk density. So this is, there's different tools out there that can give you real-time information. So this one has been a lot of fun for me as far as analyzing soils. So this is a newer soil test for myself. I think it's newer in general. It's using stronger acids. Getting an idea as far as getting your total nutrient digestion analysis will tell you your available and unavailable nutrients out in the soils. So there are large pools out there. So just to give one example, if you focus on sulfur there, it's actually 240 parts per million that is found in this total nutrient digestion analysis. Sulfur is a mobile nutrient in the soil. Typically, you want to see a regular soil test show 15 to 20 parts per million. Like I mentioned here, I'm seeing 240 parts per million. There are soil tests that I've taken as of recent, and I found anywhere from 9 to 6 actually what's out in the soil, 9 to 16 parts per million. So this is just showing how big that pool is of nutrients in the soil. And as we know, and as you talk to any microbiologist, soil microbiologist, it's the soil microbes that are needed to unlock those nutrients to become available to that plant. So this one has been an eye-opener for me. And as you go further on that right side, the fertilizer equivalent pounds of fertilizer, this is showing how big those pools are. This is showing what is needed to recreate that soil, that actual fertilizer out there. And it's, as you look down through that is a lot. So I mean, to back up a little bit, the potassium side of things, it's showing 2,150 parts per million. Typically, you want to see a range of 175 to 200 parts per million. So again, those pools are large and are very large in our soils, and we need a diverse group of microbiology in the soil to allow these pools to become um, to become available to the plant. Another couple of quick things to help monitor as far as your soils is a POFA. And again, there's a lot of different labs out there that do both of these types of testing. So just wanted to clarify that. So as far as the phospholipid fatty acid test is going to tell us our bacteria, our fungi, our mycorrhizae fungi, our saprophytic fungi is super important, that protozoa side of things. And this is a soil that, has been deep tilled. And so this one's going to be interesting because this particular grower is using Bio 800 Plus, so it'll be fun to see how things change out there as he changes some of his practices also. But so you can see protozoa, the undifferentiated, that is actually, we don't know what's in that. It could be bacteria, fungi, protozoa. There's hundreds and billions of microbes in the soil. And so that's just added to that pool also. And then microbiometer, that is one that's going to tell you your bacteria to your fungi. And again, like I mentioned, the bacteria, fungi, protozoa are all important as far as when it comes to cycling nutrients and healthy plants. It kind of moves me into as far as talking about the soil a little more. The soil, as we know, is alive. 40% of all living life on the planet does exist below the ground. And it's a breathing, living organism that requires a lot of care and attention. So the role of microbes, such as, there's such a huge need for that diverse mix of bacteria, fungi, protozoa, beneficial nematodes. You can go to that next slide. Again, the role, microbes are going to consume fertilizer, release nutrients, build that soil organic matter in the soil, organic nitrogen, sequester carbon. Such a big need as far as for that diverse mix. Just an example, we don't see a lot of protozoa in the soil, and it's such a huge need for that because protozoa must consume 6 bacteria and the output will be 5 nitrogen, which is usable to the plant. So as long as we can keep, this diverse mix and this cycle going through, it can definitely help our crops in the long run. So we are putting life back into the soil as far as using Bio 800 Plus. And I know Dr. David Stark went into detail as far as the product and everything. I think it was maybe 1 or 2 webinars ago, but just wanted to highlight some things with it again. So, Bio 800 Plus, you're getting the 400 plus species of bacteria, 200 plus of fungi, 70 plus of protozoa, 100 plus of beneficial nematodes. So along with key food sources to keep all of this living and growing and, benefiting what needs to happen in the soil. So we're going to have those food sources, some micronutrients, humic, fulvic, yucca extract, amino acids, lignin polymers. So like I mentioned, just a huge need to have that diverse mix out in the soil. I mentioned earlier as far as the soil microbes and the bricks test. So soil microbes can reduce insect damage. And what does this look like in this situation? The control had a bricks of 4, the treated had a bricks of 5.5. So that's pretty neat to see that difference there with that treatment. So basically microbes help protect from insects via feeding different modes of action. The increased bricks, healthier plant, better nutrient uptake, more sugars. Sugars dehydrate insects. increase lignin, better access to nutrients, produce more lignin, make that leaf tougher to chew, and activate plant defense genes. So again, just a quick kind of real world what we found on the Bio 800 Plus and these BRIC scores. You can go to the next one. Just wanted to bring up some field pictures, some things that I'm seeing out and about in my travels and digging through the plants, digging through the fields. So this is Iowa, Lucas County vertical tillage spring 2024 application of Bio 800 Plus, and did do some digging in a few different areas. And this is generally the average of what I found in every single area. And upon review of the plants in the Bio 800 Plus versus control, it showed that the treated side was about a stage ahead. And the plants had more lateral roots and root hairs. So taller plants, theoretically, we're going to shade those rows quicker. We've had, the past, I don't know how many years, we've had some situations with tough to kill weeds. And I see a benefit in this situation, being able to close those rows quicker. We're trying to find any way to combat water hemp and Palmer amaranth. So this is definitely something to think about. Like I mentioned, bigger plants, just about a stage ahead. We've got those lateral roots, those root hairs going to be able to access those nutrients and water better. You can go to the next slide. So we've got some corn plants here from Wayne County, and we've have a couple of applications, fall of 2024 and spring of 2025. Again, the treated side, I was able to find more lateral roots. Nice seminal roots, consistent length of nodal roots, embrace roots, getting started quicker. The stalks appeared larger on that treated side as well. And then thinking about that, I mean, when you have that larger stalk there, we do have vulnerable stages of our crops early on, I would say V8 to about tassel timeframe where, we don't want a wind event. And if we start out with a bigger, stronger plant, this could potentially help us in wind, heavy rain events. And then as far as, like I mentioned, with the soybeans, with the root hairs, the more lateral roots can access nutrients and water with that healthy, get that plant healthy early. Go to the next slide. This is in Sioux County, first time Holganix Bio 800 Plus user, spring of 2025, conventional tillage. It's all sampled in the same soil type. That's what I try to do to compare apples to apples. So the top is the treated, the Bio 800 Plus. There's 65 nodules and more root hairs and lateral roots. The bottom is the untreated and then 29 nodules. And you can see a big difference there. And I can tell you that all my digging that I've done this spring and early summer, I can find this a lot of time. It's not 100% of the time because we know there's lots of variables in the fields that we have, soil types, pHs, drainage and whatnot. But a lot of times I can see and find more nodules, more root hairs, more lateral roots with the treated side. Another field picture that I took this spring as far as the mycorrhizae fungi, it's an extension of the root. It's that transportation system, as I call it. We can adhere to the root and it grows out and across the soil and it's able to access nutrients and water. Mycorrhizae fungi is present in multiple strains in Bio 800 Plus. The 25 years I've been an agronomist, I rarely do find this, but when I've been getting into these fields that are treated with Bio 800 Plus, I'm able to find mycorrhizae fungi, and that's huge. That's important. And mycorrhizae fungi can also increase the amount of phosphate in the plant as far as facilitating that uptake. But as you see that top picture where I have fungal hyphae and the soil particle, if you look super close, my microscope, I was trying my best to get it focused, but you can see that fungal hyphae attached to that soil particle. It kind of looks like it's off in the air, but I just think that's the neatest thing as far as being able to see it working and seeing it out there in the soil. I don't know if we have either of the Boyers on right now. I don't think I see them on the call, but wanted to get some real world experiences, but there's a lot of people busy today. A lot of things came up, but I wanted to give you some of my experience, what I've been seeing in the field. And so, yeah, just to dive a little deeper as far as just a refresher on the Bio 800 Plus application, you've got the fall where you apply right after harvest, half gallon per acre, 15 gallon of water per acre. The spring side of things, apply as close to planting as possible, up to 2 weeks pre-plant or post-plant, that half gallon per acre. Again, you can apply in furrow or broadcast. I've had a lot of growers put it in with their pre-emergent herbicides and with their 32%, and that's just fine. That broadcast piece, you want 10 to 15 gallon of water per acre. In furrow, 5 gallons per acre. And like I mentioned, it can be tank mix, but we don't want to tank mix it with fungicide. I think that kind of wraps things up just a little bit. Was wondering if anybody had any questions of what I covered today as far as when it comes to looking at fields, trying to catch things early. Like I mentioned, there's a lot of tools out there that we can tap into to do that. So I really, really appreciate everybody being on and listening, and I hope you took away something from this. So thank you very much, and there will be a follow-up email after this also. So thanks for your time.